This will be the prep video for section 3.7, elasticity of demand. And actually, if you look at the notes online, the video is sort of in the middle. Again, right now, I just want to make sure that you guys can do some of the mechanics of forming the elasticity EFP, and then we will look at how to understand that a little bit better in class. So, what we are trying to form is this. It is called elasticity, E for elasticity, and it's based on P price, lowercase p, price, not profit. And so this is defined this way. Negative P times the derivative of f of P divided by f of P. And this is assuming that you have connected demand to price. So you have written demand equals some function of price. And we know that demand and price go together. As price goes up, demand goes down. It's just a matter of how quickly that happens to know how that impacts our revenue. Because we do know that we do reach a point where we have maximum revenue. So this is going to tie all of that together for us nicely in class. In the meantime, we need to find this, form this rational expression, and then we're going to have some information that will tell us what it means. So let's actually find one first, and then we'll look at the table and begin to make some sense of it. So the first one we'll do is this one. We have x equals f of p, which equals 1,000 times 40 minus p. If you want to write that out for the purposes of finding the derivative, that's fine. Otherwise, leave it in, you may want to leave it factored out for canceling purposes. So this would be 40,000 minus 1,000p. Okay, so we need to form this, the elasticity. So, negative p, let me write that down. F prime of p, F prime of this with respect to p is just going to be negative 1,000, so negative 1,000. So if you want to add an extra step, completely fine. And then we're going to take that and divide by the original f of p. So 1,000 times 40 minus p. And here is again where I encourage you to keep the 1,000 factored out because typically there's some canceling. So let's clean it up. Positive times positive, put the 1,000 in front, so we'll get 1,000 p divided by 1,000 40 minus p. Okay, the thousands cancel, so finally we get p divided by 40 minus p. So I just want you to be able to form this. Now let's talk about what this means. So let's come down here, write it a little bit more succinctly. Okay, so elasticity. We know that when price goes up, demand goes down. We know that happens. That's just the fact that we're working with. So the question is, if you have a small change in price, how big a change in demand do you have? And this will tell you that. So let's come over here. If E of P is a small fraction between 0 and 1, we call that inelastic. What that means is a small change in price will make an even smaller change in demand. It's just very small. Not very much happens. Which means that when the price goes up, because the demand has not gone down very much, the price goes up, revenue goes up. If E of P is greater than 1, we call that elastic. A small change in price is a much bigger change in demand. So small, big, kind of, I guess that's where elastic comes from. So a small change in price is a larger change in demand. That means the price goes up, but because the demand has dropped more than the price increased, our revenue goes down. And then lastly, every once in a while you'll hit this point where you're exactly equal to 1. We call that unit elasticity. A small change in price is the exact same small change in demand, which means nothing's happening, right? So if you think about how this works out then, when we're looking at E of P, initially our revenue is going up, and then we hit unit elasticity, and then our revenue is going down. So this turns out to happen where we have max revenue. So that's kind of interesting. We'll explore that in class. So let's come back over here and ask some questions. What do I know when the price is $8? Where am I on this? Am I at a point where a little change in price is going to give me an increase in revenue, or a little change in price is going to decrease my revenue? Because you would like to know that. So I simply plug it in. 8 divided by 40 minus 8, 8 over 32.25. Okay, so this falls in this category. So at a price point of $8, we know that a little change in price, if I wanted to raise it to $8.25, I would increase my revenue. All right, let's look at another one. Let's look at E of 30. So we have 30 over 40 minus 30. 30 over 10 is 3. That puts us here. It's elastic. That says at this point, at a price point of $30, if I increase it a little, my demand is going to drop more than the increase in the price, which means my revenue is going to fall. So if I'm at this point, I don't want to increase my price any farther because I'll be losing more money. So let's look at this last one, E of 20. 20 over 40 minus 20. 20 over 20 is 1. So that tells us we're at unit elasticity, which means this is where our maximum revenue is going to happen. It's at a price point of $20. Lower than that, I can increase my price and be increasing my revenue. So if my competitors have set a price at, say, 18, I could go to 18, but then, you know, I would be okay going to 18 and a quarter, 18.25, because I would increase my revenue. But if my competitors are sitting at a price point higher than that, I want to be really careful about increasing my price because I'm going to be decreasing my revenues. Okay, and so the last thing I want to introduce then, no, I guess I'll just leave that here. We will get to a point where we will also say, based on this elasticity, I can say exactly what the change in demand will be, and we'll do that in class. Revenue, I can only say it goes up, goes down, but I will be able to get a specific number on this, and it will be, this is essentially a multiplication factor for that. Okay, so let's look at, let's just do one more example. If you feel like you've got it, this is as much as we're going to do, I'm just going to do a harder F of P. Okay, so let's look at this one. X equals F of P, 1875 minus P squared. Okay, so the plan is to find E of P, and then we'll evaluate it at a couple of different price points. So E of P minus P times F prime of P all over F of P. So let's come over here, F prime, negative 2P. And it makes sense our F primes are negative because we know that when the price and demand go in opposite directions, so the slope is negative, that makes sense. All right, so let's start plugging in. Minus P times negative 2P over 1875 minus P squared. So 2P squared over 1875 minus P squared. There's not really any factoring to do there that's helpful, so we'll just leave it there. Okay, so now let's evaluate at a few places. We'll evaluate at 15, 25, and 40. I forgot to work these out ahead of time, so we will do that. All right, so E of 15, so 2 times, let's just go ahead and start doing this on the calculator. So 2 times 15 squared divided by 1875 minus 15 squared. Be careful with your parentheses, please. I get 0.2727. So this is inelastic. So we know that the revenue will be going up with price. We know demand will be going down by a small bit. Let's put in E of 25. 2 times 25 squared divided by 1875 minus 25 squared. Ooh, 1. So that tells us that this is unit elasticity. And then lastly, 40. .63. So definitely elastic over here. And actually, I'll go ahead and kind of tell you how this works. This tells us, these are like multipliers. So this says that if I have a 10% increase in price, then I have 2.27 of that. I have a 2.7 10% decrease in demand. And we know it's a decrease. Even though there's no negative sign here, we know it's a decrease because we know price and demand go separately, in the opposite direction. If I have a 10% increase in price per unit, I have a 10% decrease in demand. This one, let's say I go the other way. Let's say I have a 10% decrease in price. That means I know my demand is increasing by how much? Ooh, 11 times. So my demand is going to increase by 116.3% increase in demand. That's huge. So again, the elasticity tells you a lot about where you are on that curve, the revenue curve, and then it also tells you exactly what one change in price will do to a change in demand. Again, these price changes need to be small, just like when we were looking at marginal analysis. You can't go very far. This is an approximation that's based on a slope, so you can't go very far away from the point that you are. Okay, so that's it for elasticity.